Somewhere in a garage or a barn or the back of an estate sale nobody bothered to advertise, there is a tool. Maybe it's a hand plane. Maybe it's a wrench. Maybe it's a cast iron skillet so crusted over that you can barely make out what it used to be. It's been sitting there for decades, possibly longer, buried under a layer of rust so thick it looks more like geology than metal. Most people walk right past it. They figure it's gone, done, beyond saving. But here's the thing. It isn't. What looks like destruction is actually just chemistry, and chemistry, it turns out, can be reversed. This video is about a method so simple, so cheap, and so effective that the first time most people see the results, they genuinely don't believe what they're looking at. We're talking about dropping a completely seized, unrecognizable 100-year-old piece of iron into a container of liquid that costs less than 50 cents, and pulling out something that looks like it just left the factory. No angle grinder, no wire wheel, no harsh chemicals that eat through your gloves and burn your eyes, no special equipment sitting in a dedicated workshop. Just a tub, some water, a little electricity, and a secret ingredient you probably already have in your pantry. People have used this method to rescue antique farm tools, Victorian-era kitchen hardware, Civil War relics, and engines that hadn't turned over since the Eisenhower administration. And once you understand why it works, the actual science underneath it, you're going to look at rust differently forever. So let's start at the beginning. Let's start with the enemy, rust. It seems simple enough. You leave metal outside, it gets wet, it turns orange, it flakes apart. Most people treat it like dirt, something surface level, something you just scrub off. But rust is not dirt. Rust is a transformation, and understanding that difference is what separates the people who save old metal from the people who throw it away. Here's what's actually happening. Iron, in its natural state, wants to return to the earth. That's not a poetic statement, it's a chemical one. The iron ore we pull out of the ground has already bonded with oxygen. It exists as iron oxide. When we smelt it, we're forcing it into an unnatural state, a pure metal that the universe, frankly, is not that interested in maintaining. So the moment that iron is exposed to water and oxygen again, it starts working its way back. It starts oxidizing. It starts becoming iron oxide once more. It starts becoming rust. And the process doesn't stop at the surface. That's the part people underestimate. When you see a flaky orange crust on the outside of an old tool, there's a version of that same reaction eating inward, layer by layer, grain by grain. Water doesn't just sit on top of iron. It creeps into microscopic pores and cracks. It gets underneath paint and coatings. It finds the invisible seams and voids in the metal structure, and it sets up shop there. The rust you can see is almost always smaller than the rust you can't. That's also why scrubbing rarely solves the problem on its own. You take a wire brush to a rusted surface and you're removing the outermost layer, sure. But the reaction has already moved deeper. And if you don't address the chemistry, if you don't neutralize what's happening at the molecular level, you're essentially sweeping the floor during a flood. It comes back, sometimes within days. Then there's the matter of scale. 100 years of rust isn't a coating, it's a crust, it's a shell. In severe cases, it's practically become part of the object itself, interlocked with the original metal in ways that make mechanical removal nearly impossible without destroying whatever you're trying to save. The teeth of an old gear, the threading on a bolt, the fine detail work on a piece of cast iron hardware. These things can't survive an angle grinder. They're too fragile, too intricate, too far gone for brute force. What they need isn't strength. What they need is chemistry working in reverse. So people try. Of course they do. You've got a rusted tool, a corroded hinge, a cast iron skillet that looks like it came up from the bottom of a lake, and you want to save it. So you reach for whatever's available, and usually the first thing you reach for is something abrasive. The angle grinder is probably the most common weapon of choice. You fit it with a flap disc or a wire wheel, you fire it up, and you go to work. And it feels satisfying, genuinely satisfying, watching that rust fly off in a shower of orange sparks. Progress you can see, progress you can hear. But here's the problem. A grinder is a blunt instrument. It doesn't discriminate. It removes rust, yes, but it also removes metal. And on anything with detail, anything with fine edges or tight tolerances or delicate geometry, that's not a restoration. That's destruction with extra steps. You end up with something that's technically rust-free but also dimensionally wrong. Edges that were once crisp are now rounded. Surfaces that were once flat are now gouged. You've saved the object in name only. Then there are the chemical options. The rust converters, the phosphoric acid sprays, the naval jelly products you find on the hardware store shelf. These work on a different principle. They're trying to react with the rust rather than scrape it away. And to be fair, some of them do have legitimate science behind them. Phosphoric acid, for instance, converts iron oxide into iron phosphate, which is more stable and less prone to further corrosion. That's real. That works, to a point. But these products come with a list of caveats that tends to grow the worse your rust problem is. They work well on surface rust, light rust, rust that hasn't had time to dig in. On deep, layered, century-old corrosion, they can struggle to penetrate. They sit on top while the problem continues beneath them. And some of them leave residues, discoloration, or coatings that interfere with whatever finish you're planning to apply afterward. There are also sandblasting cabinets, electrolytic rust removal setups, ultrasonic cleaners. Professional-grade solutions that genuinely work, but they either require equipment most people don't own, knowledge most people don't have, or they're simply overkill for the kind of restoration a hobbyist, a collector, or a home cook is trying to accomplish on a weekend afternoon. Every one of these methods has its place, but every one of them also has a ceiling, a point where the rust wins, where the object is too intricate, too pitted, too far gone for any of them to finish the job cleanly. And that's exactly the gap that the 50-cent soap was made to fill. So what is it? It's molasses. Plain, ordinary, agricultural molasses. The same thick, dark syrup you might find in a baking aisle, or in a feed store, or in the back of a kitchen cupboard behind things you haven't touched in years. It costs almost nothing. A small container will run you 50 cents to $1 depending on where you buy it. And for the longest time, the people using it to strip rust weren't chemists or engineers or restoration professionals. They were farmers. That's where this method comes from. Not a laboratory, not a patent application. A barn. For generations, farmers in Australia, and later in other parts of the world, noticed something strange. Tools left in molasses tanks or in water that had been contaminated with feed runoff would come out clean. Not just cleaner. Clean. Metal that had been orange and pitted and rough would emerge looking like it had been stripped and treated. Nobody initially understood why. They just knew that it worked, and they kept doing it. And eventually word spread the way practical knowledge always spreads, slowly, person to person, through trial and error and a healthy disrespect for complicated solutions. The practice picked up momentum in the antique restoration community. Old tool collectors, vintage cast iron enthusiasts, people who haunt estate sales and come home with things their families think are garbage. These are the people who spend weekends chasing down the right kind of problem, a skillet someone's grandmother used for 40 years and then left in a shed for 40 more. A hand plane with a blade buried under half a century of scale, a set of wrenches so corroded you can barely read the sizes stamped into the metal. For these people, the conventional methods we talked about weren't always options. They needed something slow and forgiving and cheap, something that wouldn't damage the underlying metal, something that could work while they slept. Molasses fit every single one of those requirements. The mix is simple. 1 part molasses to roughly 10 parts water. Some people go stronger, some go lighter. There's a range, and it's forgiving. You don't need to be precise. You mix it in a bucket, you submerge the rusted piece, and then you wait, usually overnight, sometimes a day or two for serious corrosion. And you come back to find something that looks fundamentally different from what you put in. The reason it works isn't magic. It's chemistry. And it's actually quite elegant chemistry once you understand what molasses is doing to the iron oxide sitting on the surface of your metal. But to understand that, you first need to understand what's actually happening inside that bucket while you're not watching. So let's talk about what's actually going on in that bucket. Molasses is not a simple substance. Most people think of it as just the dark, syrupy byproduct of sugar refining, the stuff that gets squeezed out when raw sugarcane is processed down to white crystals. And that's true, as far as it goes. But molasses is also a remarkably complex chemical cocktail. It contains water, yes. It contains residual sugars, sucrose, glucose, fructose, but it also contains organic acids, and those acids are the key to everything. When you mix molasses with water and drop a rusted piece of metal into it, the solution gets to work almost immediately. The organic acids in the molasses, particularly the chelating acids, begin bonding to the iron atoms locked inside the rust itself. Now, rust is iron oxide. It's what happens when iron reacts with oxygen and moisture over time, forming a new compound that's chemically distinct from the base metal underneath. That compound is brittle, flaky, porous, and ugly. But crucially, it still contains iron. And those organic acids want that iron badly. Chelation is the process. The word comes from the Greek word for claw, and that's exactly what these molecules do. They reach in and grab onto metal ions at multiple bonding points simultaneously, pulling them away from the surrounding structure. The chelating agents in molasses latch onto the iron in the iron oxide and essentially dissolve it away from the surface, pulling the rust apart at a molecular level without attacking the base iron underneath in any significant way. That selectivity is what makes this method so remarkable. Aggressive acids would eat through everything, rust and good metal alike. But the organic acids in molasses are mild enough, and the process is slow enough, that the base metal is left largely untouched. At the same time, the sugars in the solution are doing something else. They're feeding microbial activity. Left long enough, the molasses solution actually begins to ferment slightly, and that fermentation process produces additional acids that accelerate the chelation. This is why the solution gets more effective the longer it sits, and why people who use it repeatedly often report that an aged batch works better than a fresh one. There's also a physical component to what's happening. As the rust is broken down chemically, the structural integrity of the scale deteriorates. The thick, layered buildup that took decades to form starts to separate from the metal surface. It doesn't vanish entirely. You'll still need to wipe or brush it away afterward. But it loses its grip. It becomes soft, removable, no longer bonded to the surface like armor. And the whole time this is happening, the part just sits there, submerged, quiet. No heat required, no electricity, no mechanical abrasion. The chemistry does the work entirely on its own, at room temperature, in a plastic bucket, overnight. That's what makes it feel like a trick the first time you see it, because you didn't do anything. You mixed two ingredients, you waited, and the rust came off. But it's not a trick at all. It's just a very old chemical process that almost nobody talks about anymore, doing exactly what it's always done, one corroded surface at a time. So let's talk about actually doing this. Because knowing the science is one thing, but standing in your garage with a rusted part in your hand and a bag of molasses from the grocery store is another situation entirely. And the good news is, this process is almost insultingly simple. Start with your container. You want something plastic, a bucket, a storage bin, a rubber tub. Metal containers are a bad idea because the solution will start working on them too, which is not what you want. The size of the container depends entirely on what you're soaking. A rusted hinge needs a mason jar. A cast iron skillet needs a 5-gallon bucket. A vintage tool collection needs a storage tote. Match the container to the part, and make sure the part can be fully submerged. Now the mix. The ratio that most people land on after experimenting is roughly 1 part molasses to 10 parts water. So for a 5-gallon bucket, you're adding about 2 cups of molasses, then filling the rest with water. Warm water helps it dissolve and blend faster, but it doesn't need to be hot. Stir it until the molasses is fully incorporated, and you have a dark, consistent solution. It's going to smell earthy, slightly sweet. Don't let that throw you off. Before you drop your part in, give it a quick rinse. You're not trying to clean it. You just want to knock off any loose debris, grease, or oil sitting on the surface. Oil especially is worth addressing. If there's a heavy grease coating on the metal, the solution won't make full contact with the rust underneath. A quick wipe with a rag or a fast wash with dish soap takes care of it. Now submerge the part. Make sure it's fully covered. If something keeps floating to the surface, weigh it down with a rock or a scrap piece of plastic. You don't want half the piece sitting in air. That's the half that won't get treated. Put a lid on the container if you have one, or cover it loosely. This slows evaporation and keeps curious hands or pets away from it. Then you walk away. That's the step most people struggle with. You walk away and you leave it alone. For small, lightly rusted items, 12 hours is often enough. For heavily corroded pieces, the kind that have been sitting in a barn for 30 years, give it a full 24 to 48 hours. Some people leave stubborn pieces in for a week. The solution won't harm bare metal, so there's no penalty for leaving it longer than necessary. When you come back, pull the piece out and rinse it under running water. Then take a stiff brush, a wire brush, an old toothbrush, even a scrubbing pad, and work over the surface. The rust won't need much encouragement. It comes away soft, dark, and loose. Rinse again, dry it thoroughly, and get a protective coating on it quickly. Bare metal left wet starts the whole process over again. And after all this, that would be a shame. And here is where the patience pays off. You come back the next morning, or maybe 2 mornings later if the piece was bad, and the first thing you notice is the solution itself. It's changed color. What started out clear or faintly yellow has turned a deep amber, sometimes almost brown. That's not the solution going bad. That's the rust. That's 100 years of oxidation, pulled off the metal and suspended in the liquid. The solution did exactly what it was supposed to do. When you lift the piece out, it looks strange at first. Dark, almost black in places. Not the bright, clean metal you might have been hoping for. But don't panic, that's not damage. That's a thin layer of loosened rust and iron residue sitting on the surface, and it comes off easily. That's the whole point. You rinse it under running water and start working with your brush, and what happens next is almost satisfying in a way that's hard to describe. The dark material wipes away, and underneath it, there's metal. Actual solid, real metal. The pitting is still there, because this process doesn't fill craters or rebuild what corrosion ate away years ago. It doesn't perform miracles, but the surface is clean. The rust is gone. On lightly corroded pieces, you sometimes get a result that looks almost new. On heavier pieces, what you're left with is honest metal, scarred, textured, marked by time, but stable. No more active rust, no more flaking, no more orange powder coming off on your hands. There's one more thing worth knowing. Once the rust is gone, the metal is at its most vulnerable. Bare iron and steel want to oxidize. That's their nature. They'll start doing it again within hours if you let them. So you dry the piece completely. A heat gun or a warm oven works better than a towel, and you get a protective coating on it fast. Oil, wax, primer, paint, whatever suits the project. That step isn't optional. It's the difference between a restored piece and a piece that's just starting the whole cycle over again. But if you do it right, if you coat it and protect it, what you're holding is something that was headed for the scrap pile. Something nobody wanted. And now it works. Now it lasts. That doesn't get old. Now, before you go pulling every rusty object out of the garage and dropping it in a bucket, it's worth being honest about what this method can and cannot do. Because it's remarkable, but it's not magic. Let's start with where it shines. Hand tools are probably the single best use case. Wrenches, pliers, chisels, hammers, draw knives, spoke shaves. Things with relatively simple geometry, no moving parts that need to be disassembled first, and solid construction. Cast iron cookware is another. Skillets, Dutch ovens, griddle pans, pieces that people throw away thinking they're ruined, when really they're 6 hours in a bucket away from cooking breakfast again. Old hardware does beautifully. Hinges, bolts, brackets, barn door hardware, cabinet pulls. The kind of stuff that costs a fortune to replace with reproductions but costs almost nothing to save. Vintage bike parts, garden tools, axe heads, saw blades. If it's iron or steel and it's corroded, this method is at least worth trying. But there are limits. The soak works on rust, iron oxide. It doesn't work the same way on other metals. Aluminum, copper, brass, zinc, those react differently and not always in a good way. If you're not sure what you're dealing with, test a small area or do your research first. The last thing you want is to damage something that wasn't iron to begin with. Pitting is the other honest conversation to have. What the process removes is rust. What it cannot do is fill in the craters that rust left behind. If a piece has been corroding for decades and the metal itself has been eaten away, if there are deep pits, thin walls, holes where solid steel used to be, the soak will clean what's there, but it won't rebuild what's gone. A heavily pitted surface will still be heavily pitted. It'll just be clean and stable instead of actively getting worse. Structural damage is a hard stop. If a tool handle socket is cracked through, if a casting is fractured, if the metal is so far gone that it bends or crumbles, no amount of soaking changes that. There's a difference between corrosion and destruction, and this process only addresses the first one. What it gives you, in the right circumstances, is a genuine second life. Not a cosmetic illusion, not a cover-up. Something solid, stable, and ready to work again. And for the right piece, in the right condition, that is more than enough. So now you know. You know what rust actually is, why it fights back so hard, and why so many of the usual solutions fall short. You know that sitting in a bucket of something that costs less than $1 can undo decades of damage overnight. And you know what to realistically expect when you pull that piece out in the morning. Now it's your turn. Find something rusted. It doesn't have to be special. It doesn't have to be valuable. It can be a hand plane you grabbed for $2 at a flea market, an old wrench sitting in a coffee can in the garage, a hinge off a barn door, something you almost threw away because it looked too far gone to bother with. Mix up your solution, drop it in, and walk away. Let the chemistry do what chemistry does. And when you pull it out, when you see what's underneath all that orange and brown and grime, take a picture, because that moment is worth sharing. There's something genuinely satisfying about watching other people see it for the first time. The before and the after sitting side by side. That's the kind of thing that gets people off the couch and into the garage. Pass this on to someone who collects old tools, or restores vintage equipment, or just hates throwing things away that still have life in them. Because that's really what this is about. Not chemistry, not tricks. It's about deciding that something worth saving is worth the effort to save it. A little patience, a little water, 50 cents. That's all it takes to bring something back.